Section 4.4, number 11. A projectile is fired from a cliff 200 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 50 feet per second. The height of the projectile, so you don't really have to worry about all that mumbo jumbo because they give you the formula. The height of the projectile is given by this formula based on those details that they just gave you. You don't have to create the formula yourself. And of course, the plus 200 is because the cliff is 200 feet tall. Is it feet? And so that's our vertical translation of the graph, right? Okay. At what horizontal distance from the face of the cliff is the height of the projectile a maximum? So it's basically saying find the x value for the maximum. So all we have to do is x equals negative b over 2a. Negative b is a positive 1, so negative 1 on the top. And then 2 times a, well a is this ugly negative 32 divided by 50 squared thing. So that takes some calculations, and what do you get? 39.0625. So basically 39 feet from the bottom of the cliff is where it reaches its maximum height, right? Okay. Find the maximum height of the projectile. Now we plug that number in to get the y value. Do you understand the difference between when it's asking for the x value, the horizontal distance, and the y value, the vertical maximum? Okay? So that was the answer to part A because that's the horizontal distance from the cliff. And now we plug that number in to find the vertical maximum of the projectile. So we're going to plug in, and if you want it to be as accurate as possible, you probably have to actually plug in the decimal version of that so that you're just getting your answer just as accurate as you possibly can. One thing that will mess up your answers on problems like this is just putting stuff in your calculator incorrectly because of order of operations. So you have to be really careful about stuff like that. Okay, so what answer do you get for that if you put in your calculator correctly? So if the cliff is at 200 feet already, then it's just taking the projectile up another 19.5 feet before it starts coming back down because gravity's acting on it, right? Okay, part C. At what horizontal distance from the face of the cliff will the projectile strike the water? So that is when the height is 0 because it's striking the water and the water is height 0. So we go 0 equals negative 32x squared over 50 squared plus x plus 200. And we're solving this quadratic. So we could solve it by factoring, probably not, or by quadratic formula. That would be preferable but still ugly. Okay. So then we go x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative 1 plus or minus 1 squared is 1 minus 4 times our negative 32 over 50 squared thingamajigger times 200 all over 2 times our negative 32 over 50 squared thingy. And then you work that out. I would say well, you can just plug the whole thing in your calculator at once. If you watch the video, I think I showed on the calculator how to do that. Could you see that okay? So this especially is one where you have to put parentheses the right places when you're putting it in the calculator if you want to plug the whole thing in at once. You would need to plug it in twice. You need to do the problem in your calculator twice, once with the positive and once with the negative. And you need to make sure you've got parentheses here, and parentheses here, and parentheses here in order for it to work out right. Okay, so what did we get for that? There should be 2 answers, although one of them we're going to throw out. Okay, well that's the one we're not throwing out because the other one, the other answer will be a negative answer, which indicates that it's a y-intercept or an x-intercept that would happen before the projectile even goes, because it's going off the cliff up here and then falling down there. So there's another intercept technically in the negative range that the projectile will never actually be at that point. It's just that if you consider the entire parabola and you solve it using quadratic formula, it gives you a negative number that represents that point. But we don't need that answer. We just want the positive answer, which probably is obtained by using the -1 minus the square root. Probably. The way the numbers will work out and divide out, it'll be the -1 that gets that answer, not the +1. Okay. D, use a graphing utility and graph it, and it gives you the domain. So if you remember, I showed you with the calculator, you can set the domain 0 to 200 and then do zoom fit, and it should fit your parabola nicely on the screen. Should look something like that. Then use the graphing calculator to verify your answer. So you would do your second calculate maximum and locate that point and verify that that point is at 39,219-ish, and verify that that point is at 170, right? So that's what you're doing with your calculator, just verifying those points. And then F, when the height of the projectile is 100 feet above the water, how far is it from the cliff? So then you can use that same graph and you can hit the trace button. I don't know if we've talked about this before, but on your calculator, if you hit the trace button and then you just type in the number 100 and hit enter, it should cause your cursor to jump right to the 100 mark. Hopefully it doesn't jump to this one if you're close to this one. Like, you should put your cursor over here so it's close to that one before you type in the 100, and it should jump right there. And then it should tell you the numbers at the bottom. Do you want me to go through it with you really fast to show you what it will look like? Okay. Alright, so we have to type in this whole function here. So it would be -32 squared, no, -32x squared divided by 50 squared. Now, because the exponents will happen first and then the multiplication, I don't need any parentheses there. And then plus x and then plus 200. So I guess you don't really need parentheses with the original problem. Okay, then we go to our window and we change the x-min and x-max to 0 to 200 because they gave us that in the problem. And then we go to zoom fit, so zoom 0. Shows us the path. Okay, then to verify the other answers, you go second calculate, find the maximum, make sure you're on the left side of the maximum, hit enter, make sure you're on the right side of the maximum, hit enter one more time, verify our answer is at 39 and 219. Then we will go to second calculate and look for the 0, because we haven't talked about that yet, but the word 0 refers to the x-intercepts. So if you want to find that x-intercept right there, you just use the 0. Okay, so I want my cursor to be on the left side of the x-intercept. Hit enter, put my cursor on the right side of the x-intercept. Hit enter again. So our x-intercept is at 170, okay? Then you just hit the trace button, that just puts your cursor on the graph, and just type in the number 100 and hit enter. And it jumps right to the number 100, which is located at what y value? 172. So it makes it really easy with a graphing calculator. How would you find that if you weren't using a graphing calculator? How would you find it by hand? You would plug in the 100 in for the x's, work it out, get the answer 172. Okay? Yes.